Welcome to the Predictor LimA introduction webinar. I am your presenter, Erwin Hartog van Banda. Today, we will go into the SoftNoise company, the new distributor of the Predictor LimA software. We go into the Predictor LimA software suite and the new options for the one-year rental portfolio. Then I will show you Predictor and give a short demonstration. I will also go into the support provided by SoftNoise, and then I'm open for questions and answers. SoftNoise is established in 2006 by two companies, DGMR and Stapelveld. DGMR is located in the Netherlands. DGMR Software is a division of the DGMR Consulting Engineering Company. And we are the developers of Predictor iNoise and Noise at Work. Stapelveld Ingenieursgesellschaft is located in Germany, 6 people, and they are developing on the LimA modular system, the calculation course, and the QGIS interface. Björn and EMS, Björn were the exclusive distributor of the Predictor and later the Predictor LimA software already since 1995. So we thought it was time for a change. In January this year, therefore, we started direct sales of Predictor LimA licenses, one-year rental licenses for starting at €495 a year. If you look at the Predictor LimA software suite, you see that it's a complete solution. It's for industry, road traffic, rail traffic, air traffic, wind turbines. It's a software suite. It bundles the Predictor and the LimA system in one powerful package. And it's also the first software to comply to the new quality assurance method for the Knossos EU method. If you look at Predictor and LimA and compare them side by side, you see that Predictor has a Windows intuitive graphical user interface. It's very intuitive, it's powerful, it's easy to learn. Also with one Predictor license, you can use Predictor on all computers in your network. It uses the fast LimA calculation course and is therefore preferred for most projects. LimA, on the other hand, has a very powerful command line graphical user interface. It's modular and flexible. It includes the macro language support and therefore it supports automated workflows. And it has been used for the world's largest noise map. I will show you the link to the noise map. That was the noise map of England. And in this project, England was divided up in tiles. All these tiles were calculated automatically based on the LimA macro language structure. So data was gathered, cleaned, passed on to the calculation course. The calculation course did the number crunching, then the results came back, the tiles were temporarily stored, and that has been done for all tiles, and then in total, the total noise map was configured, all done within the LimA software package based on LimA macro language. So that's a powerful step. Therefore, LimA is also preferred for GIS integration. If you look at the noise prediction methods, Predictor supports 12 methods, LimA supports 26 methods. The several methods are available in both softwares, like the Knossos, the 9613, CRTN, NPB, DAL, XPS, Harmonize. They are included in both software packages. And then Predictor has some additional methods like the TNM, ENM Link, the HD 2.4, the Chinese method, and Analyst. And then LimA supports many other calculation methods used in Germany, East Europe, and also the ACAC 29 for air traffic noise. So if you want to calculate air traffic noise, you use the LimA method. Then we also have a product called iNoise, and iNoise is for ISO 9613 only, but has the same intuitive GUI as Predictor. If you look at the new one-year rental portfolio, you see that we have Predictor Standard 7810i, Predictor Plus 7810c, and Predictor LimA 7810G, A, and B. So the standard is available for €495 a year for industry, wind turbine, road traffic, and rail traffic. Of course, the Predictor graphical user interface, 11 calculation methods, including the Analyst method, which I will also show today. And the standard, can be used for standard-sized models. Predictor Plus, €995 a year, the same application, the same number of calculation methods. However, it calculates faster, it supports more calculation cores, and you can calculate larger models, plus-size models. Then Predictor LimA, that includes the Knossos method, and both the Predictor software and the LimA software. So if you want to use Knossos, you can select one of the three configurations starting at €1,495 a year. And this is for standard to advanced sized models. So the B, the end, is the software you use for noise mapping, of large scale noise mapping, the European noise maps, for instance, complete cities. We provide more information on the Soft Noise website, and you can order directly in our online web shop. Okay, a short demonstration of Predictor. I will switch now to Predictor. Yep. This is the first dialog in Predictor. When you start Predictor, it's a welcome dialog. And it allows you to show the introduction video. It allows you to open the Getting Started tutorial, very good self-educational material and exercises. So when you start using Predictor, this is recommended to use. Then there's a demonstration project, which includes already filled models, just for looking at. And then, of course, you can open an existing project, one of the projects that you will create yourself. I will start by opening the demonstration project. I click on the Open Demonstration Project. Then Predictor opens the project and shows you the organization structure within this project. This is the organization structure of the demonstration project. And you see that Predictor organizes models within a project in areas, versions, and models. So areas and versions are mainly folders within a project, nothing more. So don't be alarmed by the name area and version. There's of course an idea behind it that most, especially authorities, will want to manage the noise inside an area, and they want to manage it by making versions in time. So versions could be seen as moments in time of this area. However, you can use it any way you like. You simply create it and you give it a name. You create a top folder by new area and a subfolder, a version, with the button New Version. So if you look at the area, this is an area, example models industry, and this is a version, a folder within the area. Ski Harbor, shooting noise, bridge construction, karting, wind turbine site. So click on the Ski Harbor version folder again. When you select such a version folder, you see the models that are in this folder. And a model has a calculation method attached to it and a name attached to it. So this model has a name, Contour Situation 2010, according to the ISO 9613 calculation method. And this model has been made final because there's a green curl behind it. Final models cannot be changed anymore. If you select the model and you click on the info button, so you get info on the selected model, you click on info, then you see that this model has been made final by the user VE, that's my colleague Theo Verheij, in 2018. And why? Because it's being used in the demo project. And so this is a way for you to make sure that if you have used your model and the results of the model in your report, that you then block the model from changes, because of course it's necessary to be 100% sure that after some years you find back exactly the model that you have used in your report. That's why we have made options to make a model final. Of course, if you want to continue with the model, you simply select it, you click on the copy button, and then a copy is created in the list of models, and then you click on the model and then you can open, and then you can continue editing the model. So this is a model. You see here all type of items in a model. You can double click on an item. This is a ground region with coordinates and with properties. The ground region has only one property. It's if it's absorptive, reflective, So if it's forest ground, uncompacted, hard surfaces, etc. And that is presented by a ground factor. 1 means 100% absorbing, 0 means 0% absorbing, so hard. In this case, it's an absorbing surface. Similar for these gray regions, these gray polygons, double click, you see it's a building. It has a name, it has coordinates, it has a height, it has a reflection factor per octave. You can also make buildings floating, just like barriers. You can also make barriers floating. And there's an information property. So this is a building. This star, double click, is a point source, also a name, a height, some other properties. You can give a directivity to a point source. Of course, the sound power level. You can enter the sound power level already A-weighted, C-weighted, or non-weighted, Z-weighted. However, Predictor will always convert the spectrum to a A-weighted spectrum, because in the end, Predictor shows A-weighted results. However, your input of your sound power levels could be A-weighted, C-weighted, or Z-weighted. And there's also a nice option here, LP, to convert a measured sound pressure level on a certain distance to a sound power level. That's very, very easy. You simply type in, I've measured this on, for instance, on 10 meters distance. Very easy spectrum, of course. And then Predictor calculates 103 dBA. And if you then say OK, then the sound power level is adapted, etc. So that's an easy way. I will not store it. That's an easy way to calculate your sound power level. There are many other ways to calculate sound power levels, but this is one. And then this is a emitting facade. An emitting facade is a surface attached to the surface of a building. It has coordinates, of course. It has a surface, almost 80 square meters. Also a sound power level, but then you can also select an indoor-outdoor calculation. So you can enter an indoor sound pressure level, then select an isolation material, and then Predictor will calculate the emitting sound power level, so the noise that's coming out of the facade. And the working hours, of course, how many hours is it active in the day, evening, and night period. So this gives you a little bit of an overview of what is a model. Then as a background map, you can enter many types of background map. So just for viewing, you can enter bitmap files, JPEG files, WMF, PNG, TIFF, shape files, MIF files, DXF and DWG files. And in this case, I already selected one that's a GPG file and just want to activate it. And then it's shown as a backdrop behind your model. You can calculate a model by start calculation. So then it calculates on every point. In this case, I've also added a grid. I have not shown you the grid item. Let me just stop this one. This is a grid, this rectangular area with all kind of grid points, and you can enter the spacing between the individual grid points, 10 by 10, for instance. Well, for sake, let's just make it 25 by 25, and then start my calculation. Well, this is a small model. Let's calculate it quickly. Okay, and after the model has been calculated, you can show the noise contours in all kind of colors. You can set the colors, the contour classes. There are several other options to do it: areas, lines, or the receivers itself. You can show the receivers color coded, labels to the receiver values, etc. This is the main, and you can make your contours transparent. So these are the noise contours transparent on top of this bitmap image. So this gives you a small idea of, let me go this one a little down. Yep. Okay, I'm going to close this one. Okay, next I want to show you how you can import data in a predictor model. Show you how to import data for the city of Arnhem. That's a city in the Netherlands. I'm going to use the LimA CRTN calculation method. This is where you select a calculation method. So these are the 12 calculation methods supported by Predictor. And there are more because the ISO 9613, we've got an octave implementation and a 1/3 octave implementation. And also for CRTN, we've got several implementations. We've got the L10 implementation, the implementation according to the New Zealand way of handling the CRTN, and the implementation with the TRL backend correction to convert the L10 to the LAQ. So there are more than 12, but basically, of course, they're all based on CRTN. So that's why we say in Predictor we support 12 calculation methods. So I select LimA CRTN, I open the model, and of course we start with nothing. This is a blank view. I'll go to File Import, and now I want to import shape files. You can select shape files, map info files, CAD files, QSI files. QSI files is interesting for exchanging data between the known software packages around the world. It's a good way of exchanging data, but in this case I want to import shape files. And let's go to my C drive, because oops, there is my, where are my C drive data, and I want to import shape files, and I've got some shape files of RNM. So I select the buildings RNM shapefile. I open the shapefile, and the next dialog allows me to select what type of item I want to create out of the shapefile. I select I want to create buildings. Then you see the item fields offered by the item fields needed by Predictor and the fields offered by the shapefile. If the names are the same, Predictor automatically matches them. But if there's no ident field in the shapefile, then you can select one of the other fields in the shapefile. So this is how you connect fields needed in Predictor with fields offered by the shapefile. In this case, it's easy because all fields are there already in the shapefile. And I say OK, import. Now Predictor is importing the buildings, and it's about 60 or 70,000 buildings in this shapefile. Save any changes. Here are the buildings. If you want to know exactly, you can open the message section underneath your model, and here you see all the steps that you have taken during your Predictor session. And I've modified an item, that was the grid item that I've done. I've imported 68, almost 69,000 buildings from the shapefile. So this is an easy way of looking back. What have I done since I've started Predictor? So this is a kind of a log. When you close down Predictor and you open it again, the log is empty. So this is only available during your Predictor session. Sometimes it's handy, sometimes not, so you can close it. You actually do not need it, but sometimes it's just handy. So these are all my buildings. If I double click, this is a church in Arnhem. If I double click, you see the height, the properties, if it's reflecting or not, etc. I can do the same for the road structure. So I select the shapefile again, and then I select Arnhem roads. And then of course I select the road item. I say OK. And then the road structure is imported. So now I've got all the roads in Arnhem. And in this case, roads already have a flow attached to it. There's traffic data attached to the roads. So what if I want to calculate only the center of Arnhem? And I don't want to calculate the full map of Arnhem, because that could take a while, of course. So let me create then a new model, and I say this is the center. Home Arnhem, Arnhem, whatever, Arnhem center. Say OK, I need to select the calculation method, LimA CRTN. I say OK, and I also open it. Now with Windows Tile Vertical, you can open them side by side. So this is my complete model. And this is my new empty model. So I zoom into the Arnhem center because I want to select only the items in the center. Right mouse click, I can select by polygon. So I select by polygon, and this allows me to create a polygon and double click closing and selecting everything that's inside the polygon. And now with a simple right mouse click copy, clicking on the new empty model, right mouse click paste, I can paste all this information that I've just selected into this new model. And so that's an easy way of copying and pasting data from one model to another. Now I can close down this model and focus on this model. Now I want to create a grid because I want to calculate noise contours in the center of RNM. So I click on the grid item, click, and then my mouse changes in a crosshair. And with my right mouse click, I can also select to create a circular grid. And this is, of course, nice. Shows nice. And then properties, again, a spacing of the grid, 50 by 50 meters, for instance. So now I've created my grid. Now I can start my calculation because I've got sources, those are the roads. I've got calculation points, those are the grid points. And now I can look at the calculation progress dialog. And I see that the calculation is started overhead when starting a calculation. You will see that the calculation will be finished within a minute. The overhead shows you that it's expected to take longer, but you already see that expected time of arrival to the end of the calculation. The predicted is 4 minutes, 3 minutes. It is already speed up. .53, so now it's almost 1 minute and 15 seconds. You can also pause a calculation. You can stop it and then resume the calculation on a later moment. So that's always possible. And then all the results up until the moment that you pause the calculation are, of course, kept. Okay, the calculation is done. Then I can show my noise contours. And here are my noise contours. The L10, nice high noise contours, high noise values. I can view the noise contours and my model in the 3D view. Here are all my values. You can rotate the model. You can, how do you call it? Show the model in various ways. And you can zoom in and zoom out with your mouse, the scroll wheel of your mouse. And you can pen with the scroll wheel of your mouse from the left to the right, etc. So, this is how you can calculate or import data and make a quick calculation. Okay, the last I want to show you is the analyst method. That's another type of method. And let me go to the Woorden. Open the analyst. Analyst is a calculation method, but it's not a calculation method for noise propagation, but it's a calculation method of cumulating noise maps. And in an analyst model, you can import data with these options here. Import data set from model. Let me scroll down this one here. Import data set from a shapefile or input a calculated data set from a text file. So these two options allows you to import data calculated by any type of software in the form of a shape or a text format. And this option allows you to import data directly from one of the calculated models in your project. So in a predictor project. Once you have imported it, the results are shown here in a tree. And you see that I've got noise results in the day period for road traffic, for rail traffic, for air traffic, for industry, and for rail traffic. And they are all imported from these text files. See that the name, the origin, the source of my results is also shown here. And Let me go to the display options. I do not want to show my point data sets. I only want to show my focus area. Once I've imported my noise maps, I also can select a 24 average value, and most likely that will be the LDEN in Europe, for instance. Then I can go back to my analyst result tree, and then you can look at the imported noise maps in the day period. This is, for instance, road traffic in the day period, air traffic in the day period, industrial noise in the day period, rail traffic noise in the day period. The night period, similar, road traffic in the night, air traffic in the night, industry and rail traffic, etc. If you click on the night, you see the cumulated values, a decibel summation of the four source types, and the similar, of course, in the day, the cumulated value in the day. And then if you click on top level, then you have this 24 average of day, evening, night, the LDEN value. So this is a nice way of showing and managing your noise maps. Then on top of that, you can also check the amount of people living within these areas. And to do that, you can confront your noise map with for instance, a zip code point for. Let me open this one. And this one is not there. Is this one there? Ah, there's another one. Okay. I need to add a file. And I want to add data. I've got some data over here. And that's the analyst example. Ah, no, I need to go back to my, sorry about that. I need to go back to my demonstration project in my documents. I go to Predictor. Where is my demonstration project? Documents. Okay. Yep, Predictor. The demo, for instance, 2020. And then I scroll down to the example data. Yeah, sorry about that. That's what I wanted to show you. I want to show the zip code point file as a background file. And then as a color, I want to use a nice color. And then all the blue maps, all the points are zip code points. On every point, there's a number of people and a number of dwellings attached. Then with my Analyze Contours option, I can use the same shapefile that I've just selected, the zip code point file, to count the number of dwellings. So I select the property of the shapefile, that's dwellings, and then Predictor calculates the number of dwellings within these 5 dB noise classes. Similar thing goes for people. Start the amount of people. And then if you want to make a nice graph out of this data, you simply copy it to the clipboard. Then you go to Excel, and then you simply paste it in Excel and create a graph out of it. Paste it in Excel, and then you say I want to insert a graph. Yep. And then you see the number of people exposed in 5 dB noise classes. So that's easily done with Excel. Okay, this concludes my short demonstration of Predictor. Let me go back to the PowerPoint. So what I've done, I've shown you the multi-model interface. I've imported buildings and roads in the Arnhem model. I copied and pasted the center part of Arnhem to a new model. I calculated the noise contours. And then I've shown you the analyst method. There are many tutorial videos for Predictor. So please go to the website and see the tutorial videos. That's always good to do. Then support, basic support in our 1-year licenses are included. That means questions regarding installation, and also the upgrades are free within the 1-year rental license. Then optional, we've got premium support, and that handles additional questions regarding the use of the software, or if you want us to make a model review, etc. And of course, we recommend all new users to include premium support for the first year, and that will really speed up the learning process and it will increase the quality of your models, of course. Okay, I'm open up for questions now. Please use the chat option for questions.